You're a good group and you like to chat a little bit. But check your homework out in the mornings. Okay. Any questions on these guys? This had a lot of points from your discrete points from the end points. I just did all of them. If you did some of them, I'm fine. As long as you get the gist of it, I'm good. If you draw your resulted one, it kind of, sometimes it makes a little sense, sometimes it doesn't. I don't know if your direction said to draw it. Did it? It did. You got it. So therefore you had to go off your points. Even if you went off your major points, you'd probably be fine. The dots that they gave you, the points that they gave you. Anybody cannot do this or doesn't understand this part? No? It's just, remember, the value that gets returned from your function is the y value. That's the dependent value. The independent is your x. You give me an x, I stick it in my equation, I come out with a y. I look at my graph with the function, I come out with my y. The value of your equation is your y. Everybody knows this. Sorry, it moves the part, it moves my... Okay. These, they actually gave you the equations. So what you had to do was plug it in, add them, ladies, add them, subtract them, whatever they, I had to do all four operations. You had to add, subtract, divide. Now, remember to worry about any domain restrictions. When you begin, look for a domain restriction. The domain here is all real numbers. The domain here, all real numbers. When you get to a divide, this is the one you want to worry about. This divide says, well, this all works well through here, no problems, until I throw in a denominator. And Isaac, what happens with the denominator? W. What happens with the denominator?
Yeah, I mean this one.
Yeah, I did. You cannot have 0 in your denominator, so you set your denominator to 0, just like you do all your domain restrictions, and you take it out of your domain, whatever causes it to be 0. This is the only one that's going to snag you. So set your domain on your divides. Everything else was all real numbers. Good. 5?
Yeah, 5. We don't have the negative x on it. We had it.
Wait, say this again?
Is there a negative sign on the x? I can't see it from here.
No.
Oh, that sign is an equal sign? Okay, I can't see it from here, so I wasn't sure if that was a minus sign.
Which one are you looking at, A, B, or C?
No, the original equation.
The original equation?
Yeah.
Yeah, no negatives.
Okay, it's an equal sign.
Yeah, it's an equal sign. Yeah, no negatives. Be careful on your subtract that you make sure you distribute this. How many of you got snagged on that one? Did you all remember to distribute it? You gotta remember those parentheses. Remember, you're subtracting the whole function, not just the first term. That one still snags everybody. Remember to distribute, and what else would keep you brief? That's probably it. And the division. This one, same process. Collect your like terms, do the subtract, make sure you distribute. You find all the way down to your divide. Your divide says your denominator cannot be 0. So take that 1 out of your domain and give me a restricted domain for that one. Good? It's the same process as taking it from your graph. I mean, it's probably, you just have to plug it out. These are different when I do this. Okay, 7 and 8, 9 and 10. You can do them with your numbers. You can do them with an equation first, or you can do them individually with their numbers, whichever way you wanted it to do. Since you're only doing one of them, easiest way is just use your numbers. You can come up with an equation like we did yesterday and then plug the number in. But if you're only going to do one of each, just start like this. Take your 3, plug it into the G. So we plug the G into 3, plug your G into the and plug your 3 into the F. We plugged it into F. And we're adding them. It's the same as if you did one equation. If you did this, and you gathered up your terms, and then you plugged in your 3. It's kind of like your composition of functions. It works the same way. And it would come out to be 9. I would do the equation only if you had more than one numbers to do. If you only have one, do the numbers. Everybody understand this? Good? Questions on any of those? I think the numbers selecting are probably far easier for you because there's no domain. There's no distributing your negative. Good. It makes your multiplication a little easier. All right, number 11. This wanted you to find f of g and g of f. Really, ladies? And the domain of f of g. On the block now. All right. Remember now, f of g and g of f, they're not always commutative. They're only the same. They only break down to the same when you have an inverse. We didn't get to inverses yet. So they're not a commutative property. So you have to do both of these. Put g into the f and put f into the g and work it out. You plug your g into here, into this guy, and you end up with that. The opposite way, you plug your x into there. When you square a radical, it comes out. Therefore, you can see that they're not equal. So I only wanted you to find the domain for the f of g, and actually either one, because there's no division here. This is the only one that's going to hang you up. So in a radical, it cannot be negative. So we take out what's in the radical, and we set it greater than or equal to 0. This is your domain for both. I said for one, but this one works for both because they're interchangeable that way. You had no domain restrictions on the other one. Okay? Maybe the directions were a little bit confusing. F of g, these are your compositions of functions. Same thing with the number 12. Again, you started out with no domain restrictions. How come the first one, how come f of x doesn't give a domain restriction? It has a fraction. It has a fraction. Why don't it have a domain restriction? It's not in the denominator. Good. Nothing's being put in the denominator. That x, when you do 1/3 times x, where does the x go? In the numerator. There's no variable in your denominator, so you have no domain restriction. Doesn't matter what x is. I can plug anything in there. Okay, so f of g and g of f, in this case, they turn out to be the same thing. They turn out to be x. What this means is they're inverses of each other. They have, if you graph the two of these, it'll be a reflection over your line y equals x. And the reflection, over your line y equals x, if you think about it, if this is 1, 5, and this reflects, this is 5, 1, it takes these and it flips these around. So your xy becomes yx. Okay, so there's your reflection. So if you look in your table, you can take your original point and see that it reflected. We'll get to inverses. I don't care if you realized it was an inverse, but we'll get to inverses. Can you do this, though? Anybody can't do this? No? We're just too lazy to do it last night? It just required a little bit of thought? A little bit. This probably was the easiest part. The part that nobody even got to. I shouldn't say nobody, some of you got it. All you're doing is returning your value and then adding it. So when G is 3, remember when you plugged it into the G equation, then you plugged it into the F equation and you added it? You're just using your graph. This is the F, this is the G. So when G is 3, what is the value of your equation? 1. When F is 3, what is the value of your equation? 2. Add them together. That was it. When G is 2, the value is 2. You're going to divide by this. When F is 2, the value is 0. You can do 0 divided by 2. This is your composition. It's got a little O in the inside here. That's a composition. Do the G equation. So come to G. What is the value when G is 2? 2. Plug 2 into the F. What is the value? 0. This is the opposite way. Type F at 2. What is F at 2? What is that value? 0. Plug it into the G. What is that value? 4. This should be easier on the graph. Any questions at all on these? It is kind of like the last part we had to do for this, and it just kind of gave us, let's put this in your calc and give me a sketch. I would always start whenever you pick up your calculators, especially if they're the yellow ones, do a zoom 6, because you never know what anybody's doing here, or what you should do yourself. So start off with your zoom 6. Okay. What do you notice from your screen? What are you going to have to do? No, don't zoom. Don't zoom. Try not to zoom. Change your window. So watch. Right now my window is like this. And on my graph, I can see this part here, but it's not turning over here. I need to move this down. So what am I going to change in my window? Y, min. Anytime you have a vertical change, vertical shift, that's the Y. Go to your Y min and double it. Rule of thumb, just double it. Hit window. Just go to your Y min, make it -20, and hit graph. Can you see it? Okay? So, make sure you're able to. Try not to zoom because most of the time in here we have to change windows.
So what am I choosing?
Just double it, -20. Rule of thumb, I just double. You can look at your table and see where your lowest point is, but it doesn't matter where it is. You just need to be able to do a min and max. Okay. Mins and maxes. Are these guys relative mins or absolute mins? What are they? Absolute mins. They're absolutely the minimum point. And I'm not really sure that they're the same point yet. So how about we do, everybody remember how to do a min? Second calc, min, move to the left, hit enter, move to the right, hit enter. Okay. Absolute mins. Point A and B. Label it with a letter. It makes life a little easier. And for me too when I'm looking for it. So find me your min. I don't know. What does it say error for? Found. So for some odd reason, that's the part that you have to worry about when it says error. Show me what you did. I'm lucky. No. You probably just didn't move it to the other side, so it couldn't be where it was. It might have been. Yeah, you went backwards. So you gave it like a reverse look. So anybody come up with a min? Okay, how many decimal places? 3. Is that it? Okay, now, an easy way to check to see if you have symmetry is to do second calc value and put in positive 1.414 and see what should that y come out to be. Negative 12. So do this. Second calc, 1 is value. This is where you put your x value in. Of course, it's not going to be exact because we're rounding this, but your y should come out to be real close to that. We round it. When it's an exact value, it works perfectly. When it's rounded, it's a little bit off. Okay? So now, you know the other one. We therefore know you have symmetry. God bless you. Okay, what is point C? What would we consider point C? God bless you. Is it our relative min, absolute max, relative max? Relative max. It's a relative max because it's maximum to this area relative to this spot, but my max is indefinite, my absolute max. So do a max, or an easy way to do this, if you think it's the 0, 0, look at your table. Does your table show you 0, 0? Yeah. So therefore, 0, 0. Now remember, sometimes when you do this on your calculator, it'll show you a number and then it'll say e to the negative 7. That's at 0. It's moving the decimal place 7 positions over. That is 0. For some odd reason, it always comes out a little bit strange. All right. To show your intercepts, we've got a y-intercept and an x-intercept. X-intercept is when y is 0. So plug this in. And if you get confused, it doesn't matter. You're going to do both anyways. So one gets set to 0 one time, the other gets set to 0 the other time. If you forget which one is which, so we can put the intercept word up there, just say intercepts. And I'll know what you mean. So now we have to factor this. What can we factor out? 3 and an x squared. Good. And what's left? Minus 4. Good. So we set these to 0. See your double root right here with the x squared? That's why we should have gotten 4 roots, and we'll factor this. But we only have 3 because one of them is a double. I'm okay if you break this down and just say x squared equals 4 and do plus or minus 2. That works for me. I just did it out the long way. And this is a 0, 0. And I realized that since you already found the 0 for the y, you're still going to have to do it again algebraically. Plug your x in for 0. This one works real nice. 3, 0 to the 4, minus 12, 0 squared. This is your 0. Just show me algebraically. So we got your intercepts, we got your max and your mins. We're going to do your domain. We forgot your domain. What's your domain for this? All real numbers. Now, your range, we couldn't do your range until we found your absolute minimum. So how would I write my range? Negative 12 to where? Infinity. Good. Remember, you're reading from the negatives to the positives. So negative 12 is the lowest it could go. Then it goes higher. So negative 12 to infinity. Okay? Increasing, decreasing. Increasing, decreasing, go off your x values. So if it helps you, put your points out here. And positive 1.414. Okay, so this is coming down, down, down. We're decreasing. We're decreasing from negative infinity. We stop when we hit this x value, negative 1.414. From this x value to this x value, our value of our function is increasing. So we're increasing from negative 4.14 to 0. From this x value to this x value, our value of our function is decreasing. So from 0 to 1.414, we're decreasing. And then we're increasing from this x value to infinity. Now, because your domain is all real numbers, your increasing, decreasing should cover all your real numbers. So you went from here, negative infinity to 1.414, from negative 1.414 to 0, from 0 to 1.414, from 1.414 to infinity. It covers all your numbers. It has to. Okay? And odd and even, we're going to substitute in a negative x in here. What do you think it should be? Even. Because where's your symmetry? Y-axis. And when you square to an even number, it comes out the same. So therefore, since it's the same, this is even. This is an even function. Okay? You got to do all the parts to it, but it's not bad. Do your sketch. Do your max and mins first. That'll help you find your range. The cubing one is nice that you're going to do next because you're cubing your domain and your range are all real numbers. So bring this back tomorrow. We'll work on it tomorrow. As long as